Today we're going to learn how to calculate speed from a graph. Question 1 says, what is the average speed of the bike above from point A to B? We already know that to find speed, you calculate by using the equation speed equals distance divided by time. So the first thing we have to do is find the distance traveled from point A to point B. The red arrow shows us where point A's distance is. So we look at the point on the graph and look to the left to see that it's between 0 and 2. That means that the distance at point A must be 1 meter. That was the starting point. Now to move up to point B, we'll move the arrow up to see that point B is at 2 meters. So that change from 1 meter right here up to 2 meters is just 1 meter. You could do that by thinking about it. 1 up to 2 is only 1 meter. Or you could do a subtraction problem and think, now we need to find the time by looking at the graph as well. So we are going to see where point A starts at 1 second and point B is all the way over at 3 seconds. The difference between 1 second and 3 seconds is 2 seconds. So it took 2 seconds to go from this point to this point. And again, you could just think about that, and if it makes sense to you, you'll realize that it's 2 seconds. Or for some people, it's easier to do a subtraction problem to think 3 seconds minus 1 second equals 2 seconds. When you use your calculator to divide 1 meter divided by 2 seconds, we get 0.5. So our answer here is that the speed of the bike is 0.5 meters per second. For problem 1b, we are going to start at a different point on the graph. We will start at point B and move to point C. We are still going to use the equation speed equals distance divided by time because we are still trying to find the average speed. The starting distance is 2 meters. When we move up to point C, we move up to here. This is between points 4 and 6, so we can figure out that that must be 5. So we started at 2 and we moved up to 5. You could think about that and decide that moving from 2 to 5 means that we rose up 3 meters. If it's difficult for you to figure that out, you can subtract. 5 minus 2 equals 3. Now we have the distance, but we also have to figure out the time. We started at 3 meters, and when we get to point C, we are now at 5. So when you move from 3 seconds to 5 seconds, you may realize that that is a 2-second difference. Again, if it's difficult for you to just think about it, you can do a subtraction problem. 5 seconds minus 3 seconds equals 2 seconds. In order to figure this out on my calculator, I would do 3 meters divided by 2 seconds to get the speed. This would be 1.5 meters per second. If you feel comfortable with these problems, you may start doing them yourself and then watch the video to make sure that you did them correctly. Problem 1C is going to start at point C on the graph and go to point D. We want to know the speed from point C up to point D. So the first thing we need to look at is distance. When we look to the left, our distance for C is at 5 meters. When we get up to D, we're right here in between 14 and 16 meters. Since it's between 14 and 16, we can figure out that it has gotten up to 15 meters. So the distance rose from 5 meters up to 15 meters. How much did that rise from 5 up to 15? The answer for the distance is 10 meters. If you weren't sure about that, you could have subtracted 15 minus 5 to get 10 meters. That tells us the difference between the two distances. To get the time, we started at 5 seconds and we ended at 7 seconds. So we went up 2 seconds. When I calculate that on my calculator, I have 10 meters divided by 2 seconds, and that equals 5. So my answer is 5 meters per second. Every second, the bike went 5 meters. For problem 1D, we are starting at point D and we're ending at point E. We are using the equation speed equals distance divided by time again. So first we need to look at the distance. Again, we're looking at the distance that it rose from point D to point E. We started at 15 meters for point D and we ended at 15 meters for point E. So think about that to yourself. Have we risen? Has the distance increased? Hopefully you're telling yourself, no, the distance has not increased. So we've gone 0 meters. We can still look at the time from 7 seconds to 9 seconds. It has been 2 seconds difference. You might know that anytime you divide by 0, you end up with 0 again. So 0 divided by 2 would just be 0. We have not gone any distance, so my speed was 0 meters per second. Remember, if you feel comfortable with this process, you should start doing the problems on your own instead of watching the video first. You can always watch the video afterward and check your work. You will become better at doing the problems by trying them first than just watching. Problem E. From point E to F, what was the average speed? The distance at point E was 15 meters. So the first thing we need to figure out is how much the distance increased, or how much we rose on the graph. So starting at 15 and ending at 18 meters, we can tell that we have risen 3 meters. When we look at the time, you start at 9 seconds and ended at 11. The difference between those two times is 2 seconds. When I divide up my calculator, 3 divided by 2, I end up with 1.5 meters per second. We are now going to look at the questions on the rest of the page. Question 2 says, look at the speeds that you calculated above. Which section of the graph ended up with the fastest speed? Have you found it? Hopefully you notice that 5 meters per second was our fastest speed. All of the rest of the speeds have smaller numbers. So from C to D is our fastest part of the graph. The next question asks you to look at the slope of the graph at that point. So when you look at the graph from C up to D, does it seem very steep, meaning very straight up? Does it seem very gentle, as if it would be very easy to walk up if it was a hill? Or does it have zero slope, meaning it's horizontal and straight across? You should have answered that it is a very steep slope compared to the rest of it. So very steep would be your answer on this part of the graph. The next question asks us, where is the object motionless? Motionless means that it's not moving. So when we look at the graph, we want to look for a part where it's not moving or where the distance is not changing. Have you found that part of the graph? It's right here from D to E. The distance stays constant, so that means that we have not changed. So your answer for that part should be between D and E. The next question says to look at the graph from points B to C. Was the bike moving or at a constant speed here, or was the speed changing? So when you look at just point B to B to C, that's a very straight line. That means that as we move, the distance is changing at a steady pace. The bike was moving at a constant speed. Write that down as your answer on your paper. Question 5 asks, how would a part of the graph need to look if the object was changing speed or accelerating at the time? We just discussed that if an object was moving at a constant speed, we would see a nice straight line. When we see that an object is changing speed, we would see that that object is going to be, or that graph is going to be curved. So please write down in your paper that it would be a curved line. That means that it was changing speed. Number 6 asks, is speed positive or negative? Look back up at your answers for number 1. Do those answers right here seem like they are positive or negative? You should have said positive. Please write that down as your answer. Number 7 asks about the slope of a distance time graph. That means the slant of the line or how much it's tilted. What is that equal to? The slope of a line on a distance time graph is equal to the speed of the object. If it is a very steep slope, we know that the speed is very fast. If it is a very gradual slope or gentle slope, then we know that the speed is slow. Look at the graph on the back of your page. Number 8 asks you to find the average speed of the car in this graph at each different section. From point A to B, we need to use this equation, speed equals distance divided by time. So think to yourself, what is our first step? Your first step must be to find the distance. So looking at the graph, our distance would be the miles on the left, not the hours at the bottom. We start at 0 miles. When we get to B, we are all the way up at 150 miles. So to find the distance that we traveled from point A to B, you need to decide how many miles did we travel when we went from 0 to 150. The answer to that question is 150 miles. Now we need to find the time. We started at 0 hours and we drove until point B, which was between 1 and 2 hours. Think to yourself, if it's between 1 and 2, about halfway, what decimal do we use? 1/2 is equal to 0.5. So we would say that we drove here for 1.5 hours between points A and B. When we divide that on our calculator, 150 miles divided by 1.5 hours, you should end up with 100 as your answer. We always want to use units after our numbers when we write an answer. So if you look at the units we've used in this problem, we've used miles and we have used hours. Miles is the unit for the distance. Hours is the unit for the time. Once we've divided, we put them together to say miles per hour, because speed is a measure of both distance and time. Problem 8b asks about the average speed from point B to point C. We're using the same equation we've been using throughout this entire worksheet. Speed equals distance divided by time. So you need to find the distance first. Point B started at 150 miles. When we went up to point C, we get to 200 miles. So the distance between point B and point C would be the same as the difference between 150 miles and 200 miles. What is the difference between this? How much did we rise from 150 up to 200? If you're not sure, you can subtract 200 minus 150 to find the difference. When we do that, we should end up with 50 miles, being the difference between 150 and 200. Now we need to figure out the difference in time. We were at 1.5 hours. When we get to point C and look down to the hours, we're between 2 and 3, pretty much in the middle. So this would be 2.5 hours. You have to think to yourself, what is the difference between 1.5 and 2.5? If you're not sure what the difference is between those two numbers, then you can subtract 2.5 minus 1.5. That will tell you the difference between the time at point C and the time at point B. You should have ended up with 1 hour. When we divide 50 divided by 1, you just end up with 50. Anytime you divide anything by 1, you end up with the original number. Please make sure to add the units at the end, miles per hour. Now we'll look at problem 8c. Make sure that you have at least tried this on your own before watching this segment of the video. You can pause it if you haven't done so yet. At point C, the distance is 200 meters. At point D, the distance is 250 meters. So think to yourself, what is the rise between 200 and 250. How much distance has that car covered from point C to D? You should have answered 50 miles. Now we need to look at the time from point C to D. The time for point C was right here between 2 and 3. We had decided during the last problem that that would be 2.5 hours. Now if we look at point D, we move down to the time on the x-axis and see that it's between 4 and 5, pretty much right in the middle again. So the time for point D would be 4.5 hours. We started at 2.5 and moved up to 4.5. So think to yourself about what the difference would be. If you're not sure, remember you can subtract when you want to know the difference between two numbers. I'll use my calculator to subtract 4.5 minus 2.5. Then I know how much time passed between those 2 points. My answer is 2. So there were 2 hours in between point C and D. When I divide this, 50 miles divided by 2 hours, I get 25 miles per hour. That means each hour the car drives, it gets about 25 miles further. For problem D, we start at point D and move to point E. We need to figure out the average speed. In order to do that, we need distance and time. The distance for point D was 250. The distance for point E was 250. So think to yourself, how much did the distance increase from point D to point E? How much did the graph rise? You should be saying to yourself, the graph didn't rise. From point D to E, the distance stayed the same. If that's the case, then the distance was 0 miles from point D to E. We started for the time at 4.5 hours, and we ended, when we look at point E, right about 5 hours. So I could think, what's the difference between 4.5 and 5? If you're not sure, subtract. 5 minus 4.5 is 0.5. So between points D and E, 0.5 hours passed. When we divide that, we should end up with 0 miles per hour. Look at the speeds that you calculated above for problem 8. Which section of the graph ended up with the slowest speed? Technically, the right answer would have to be from points D to E, because there we were going 0 miles per hour, or we were stopped. The intention of the question was to see where we were going the slowest, however, as we were moving. So which moving speed was the slowest? That answer would be 25 miles per hour, or points C to D. What do you notice about the slope of this slow section? If you look at this from C to D, is that very steep, meaning it goes very straight up? Is it very gentle, meaning it's pretty flat? Or is it a slope of 0, a completely horizontal slope, meaning a completely sideways line? For this section from C to D, it was a very gentle slope. The next question asks us where the car was motionless. Motionless means not moving. So look at the graph and find a place where the car was not moving. The distance when a car is not moving would not be changing. Do you see between points D and E how the graph is completely flat? The distance is not changing. That is where it is motionless. Number 11 asks for you to look at the graph from point A to B, right here. That is a very straight line. When we look at that, does that tell us that there is a constant speed or that the speed is changing? There is a constant speed whenever we see a straight line on a distance time graph. We are covering the same amount of distance each time an increment of time passes. Is the speed of the car positive or negative? Take a look at the speeds you calculated up here for problem 8. 100 miles an hour, 50 miles an hour, 25 miles an hour, and 0 miles an hour. Did we have any negative speeds? No. So the answer here would be positive. Speed is always positive. The slope of a distance versus time graph is equal to the blank. What should fill this blank here? The slope is the slant of the graph, whether it's more of an uphill or more of a flat line. That tells us whether the car is moving fast or slow, or it tells us the speed. Please make sure you have speed recorded on your paper. What is the speed of the object in this graph from point A to point B? Please try to do this on your own if you haven't already before watching the video. You will learn more from trying it yourself first. Pause the video if needed. The first thing we need to do is use the equation speed equals distance divided by time. It helps to write that down on your paper when you do a problem like this if you don't already have it recorded. When I look at point A, I need to figure out the distance for point A and the distance for point B to figure out what the distance in the problem should be. How much did the graph rise from point A to point B? You should have said 40 meters. It started at 0 and went up to 40. That means that there's 40 meters that have been traveled. Now I need to find the time. I started at 0 seconds, and when you look at B, we went all the way to 5 seconds. So from 0 to 5, that means that there were 5 seconds total. In order to find the speed, we need to divide. So we'll use a calculator to do 40 divided by 5, and we end up with 8. Think about what units we should use. We are not traveling in miles per hour in this graph. We've used different units for speed or for distance and different units for time here. Did you say meters per second? Hopefully you did. The final question on this worksheet asks you to look at the graph. Was the object in this graph moving at a constant speed, or was the speed changing? As we go from A to B, I want you to look at the graph as a whole. Is this a very straight line or a curved line? It's pretty curved. Since it's curved, that means that we're going different distances as the same amount of time passes. I can see from 2 to 3, I only went a little bit of distance, But when I move from 3 to 4, there's a lot of distance in the same amount of time. That means that the speed is changing. Please record that on your paper. Congratulations, you're finished.